Hey there, Year 12s. In this video, we're going to go through how we determine the rule for a parabola. So in these questions, what you'll be kind of looking at is either some information about a graph or potentially a picture of a graph. And our job is to try to figure out what equation would produce that graph. So it's kind of like a backwards graphing question. And so typically, the method we choose to do this will depend on what information we have. So if we know the x-intercepts of our parabola and one other point, then we can actually start with an equation in sort of factorized form where we write a times bracket. And the x-intercepts, if the x-intercepts are n and m, then the brackets will be x minus n and x minus m. And the only thing we won't know then is the value of a, which is like a dilation factor. And we will get that by subbing in the other point. If it's a question where we know the turning point of the parabola, then it's easiest to use turning point form. And then typically what will have to happen is we'll need to know another point on the curve to sub into the function. If you know 3 points on the graph, but you don't know whether they're the x-intercepts or the turning points, so we just know any 3 points on the graph, we tend to sub this into the expanded form of a quadratic and then solve 3 equations simultaneously for A, B, and C. So again, it's going to depend on how the information is given to you in the question. Let's try a couple. So question 16, or example 16 says, determine the equation of a quadratic that passes through the points -2, -6, 2, 6, and 10, -18. So you can see none of these are x-intercepts. We don't know whether any of these points is the turning point. And so we are going to use the sort of expanded form. So we're going to start with y equals ax squared plus bx plus c. And the way we're going to have to solve this is to sub each point in and then set up equations to solve for A, B, and C. Now typically, and it won't work this time, but typically if you've got any coordinates with zeros in them, it's good to sub them in first, because occasionally what will happen is you might be able to sub in a point and kind of get the value of C straight away, for example. But as I said, in this case, that's not going to work because none of our coordinates have a 0 in it. So let's just do them in the order we were given. So let's sub -2, -6 first. That will give us -6 equals a times -2 squared plus b times -2 plus c. So -6 equals 4a minus 2b plus c. Let's call that equation 1. We're going to sub next point, which is +2, 6, into our general equation, which gives us 6 equals a times 2 squared plus b times 2 plus c. So 6 equals 4a plus 2b plus c. Let's call that equation 2. And finally, we're going to sub 10, -18 into our equation, which gives -18 equals a times 10 squared plus b times 10 plus c. So -18 equals 100a plus 10b plus c, and let's call that equation 3. Now, if this is calculator allowed, you'd be able to use the simultaneous equations template to generate 3 equations, type the equations in, get the calculator to solve for A, B, and C. But it is possible that you might get asked to solve simultaneous equations without the use of a calculator. Without the use of a calculator. So we can still use substitution or elimination when there's 3 equations. It's just that sometimes it gets a little bit trickier. So what you might look for is there an easy way to sub one equation into the other? Like, does one of the equations already say A equals or B equals? Or are there 2 equations that have some matching kind of coefficients where we could use the elimination method to eliminate one variable or potentially even 2? And if you look really carefully at equations 1 and 2, they both have a positive 4a in them, and they both have a positive c in them. So if we were to subtract one of these equations from the other, we would actually eliminate the a terms and the c terms and just be left with b. So that's probably a good starting point. So let's do equation 2 take away equation 1, and we'll do this really carefully. So reading from left to right, we're going to have 6 take away -6, which becomes 6 plus 6. We're then going to have 4a take away 4a, that's 0. We're going to have positive 2b take away negative 2b, which is really positive 2b plus 2b, so plus 4b, and then c take away C is going to give us 0. So you can see we've eliminated both A and C to just be left with 12 equals 4B, and therefore B is equal to 3. So that's great. We've got one of our variables solved already, and that means we just have to now try to solve for A and C using the other equations that we have. So if we now know that B is equal to 3, each of these equations can kind of be updated as well, so that they only have A and C in them. If we look really carefully at, I guess, any of the equations here, given that we're still wanting to solve for A and C, we might want to go and use some substitution. For example, we could rearrange one of these equations to make C the subject. So let's take, it probably doesn't matter too much if we were to choose equation 1 or equation 2. I'm going to choose equation 1. Equation 1 is now going to become negative 6 equals 4A. Now it's minus 2B, but we know that B is 3. Plus C. So negative 6 equals 4A minus 6 plus C. Now if I add 6 to both sides, actually both of these minus 6's become zeros. So actually we just get 0 equals 4A plus C. And now I can write that C is equal to negative 4A. So that doesn't give me a solution yet. Oops, sorry, went off screen a bit there, I think. That doesn't give me a solution yet, but now I have something that I could sub into one of the other equations. So we could sub C equals negative 4A into equation 3. And that gives us, actually, why did I use equation 3? That's right, let's go with it. Negative 18 equals 100A plus, now again it's 10B, but we know that B is equal to 3, so that term becomes 30. And we've got plus C at the end, but actually that's going to be minus 4A. So instead of writing plus C, we're going to write minus 4A. And now this equation just has A's in it. I don't know why I chose this equation, it's got the bigger numbers in it, but anyway, we'll make it work. So negative 18 equals, well, we've got 100A take away 4A, so 96A plus 30. Need a bit more space here. Take away 30 from both sides, we're going to have negative 48 equals 96A. Divide both sides by 96, we're going to get A equals negative 48 on 96. Like I said, don't know why I picked the equation with the biggest numbers, but we'll get there. 48 is actually half of 96, so this is just a half. So we now have A equals a half, and because we can sort of take this connection that we had with C equals negative 4A before, my diagram's going to look a bit weird, but anyway, C equals negative 4 times A becomes C equals negative 4 times negative a half, which just equals positive 2. Right, so what do we have? A equals negative a half, B equals 3, C equals 2. So let's write that down nice and neatly, because that working got a bit messy. Those are our values of A, B and C. So we now can write down the equation of the quadratic that passes through those points, which is, getting a bit messy with my space, y equals negative a half x squared plus 3x plus 2. That wasn't the nicest working, but that will be our answer for that question. And it is important that we actually determine the equation. That's what we're asked to do. So we can't just stop once we've got the A, B and C values. We have to write our final answer as that being the equation. All right. Another example here, this time we're given a picture of a graph. And what we can see from this one, again, we're being asked to find the equation of the parabola, but this time we actually know the turning point, and we know another point on the graph. So there's a couple of ways we go about this one, but I think the easiest way is probably to use turning point form and say that our equation is going to be, well, I guess our general turning point form is x minus h, a times x minus h squared plus k. If we know the turning point is at 3, 2, the turning point is essentially moved from the origin right by 3 up by 2. And so inside the bracket, we need to have an x minus 3. At the end of the equation, we need to have a plus 2. The only value in the equation we don't know yet is the value of a. Because a is a dilation factor, so a is not influencing the turning point position. So that's why that's the number we don't know yet. But we can sub in this other point, 5, 0. To find a. So if we sub in y equals 0 and x equals 5, all we'll be left with to solve for is a. So working this through, we get 0 equals a times 2 squared, which is 4. So take away 2 from both sides. Divide both sides by 4, we get a equals negative 2 on 4, which is negative a half. And now we know all the bits of our equation. So again, write down your final answer nice and clearly. And that's the equation of our parabola. So, as I said, a couple of different ways that you can be asked to find equations of parabolas. This one we could have done a few different ways. If the question doesn't specify which form to put your equation, choose the way that I guess seems like it's going to be easiest to you and that you feel most confident with. But hopefully that's given you a good idea of how to find equations of parabolas.